How many of you are from MEP here? Perfect. So are you using BIM in your design? Very nice. So now I just want to go back. When you start BIM, so BIM was a process, right? So process means the efficiency. The efficiency means that if you take the data from one stage to another stage during your design, what are the consequences, means how it's going to flow the data from your day one of the design till you hand over the project. So we're going to look at those aspects of it. So going back to the basics of BIM, where people use it for a lot of stuff, for example, coordination, quantification, and all that. Now we'll concentrate on design and fabrication for this session. So we call it a bit of connected BIM, which is actually the desktop applications and with the cloud solutions available. Now, being a MEP design solution, I just want to put this into perspective. So what we have seen is, based upon the portfolio of the products for MEP, what we have today, the existing services in your company, you are able to do more now because of the products available, because of the details we can provide. So what we are trying to do is we are trying to connect the engineering, means the MEP engineers, to the detailers, to the fabricators, and taking it on the site. How do you install those services actually on the field? Now, what's going to be happening is it's going to give you more broader services to work on. It will allow you to have, maximize those margins and the workflows. Also meet the requirements of BIM mandated by the owners and the governments in different parts of the design, and make you more collaborative in the multidisciplinary team. Now, MEP at a concept design. So if you are aware, we had no tools for, single line diagram in Revit. So what we did in 2018.1 is we introduced something called as P&ID modeler in Revit. So what is going to happening here is, Revit, again, is a foundation of BIM here for MEP, where you're going to do design, you're going to do modeling, you're going to do documentation. You're going to use the model for coordination with other services. You're going to do the simulations. You're going to take it for detailing, fabrication, and installation. But there are other tools in the process which you'll be using to fulfill all requirements in the field. Now, this is something which we call as connected BIM or connected P&ID here. So this is a module available now in 2018.1, which is, I think, a month back released. So what's going to happen here is we'll use a software available to us called AutoCAD P&ID, or Plant 3D portion, where we'll be creating this P&ID, which is meant for the schematic design of your buildings and the plants as well. Then we'll bring that P&ID inside Revit, and we'll use that P&ID to map all the MEP ductworks, pipeworks, or if you have created, the equipments and all that. So what's going to happen is your schematic as well as your detailed model will be connected. So there will be a relation between them. You will see what is not as per the schematic design approved earlier. Now, what's going to happen here, this is a schematic tool, or the P&ID tool, where we're going to create this schematic here. So this is meant for schematic. And then what we do here is we share the project. So there's different people who create this one. It's an AutoCAD environment where you create the P&ID or schematic design here. So we're going to share this project. And once the project is shared, it's a cloud sharing here. We call it BIM 360 team in this case. And this project will be available online as well. So you can view this project or the P&ID online if you need to. So all those required settings and everything will be uploaded when we share to the others. Now, once it is done, next thing is in Revit. So you'll find this right-hand, this new window coming in inside Revit, which is saying, P&ID modeler, and you log in, and after logging in, you will go and select the project which you need to connect into. You select the project, and you're going to say Open Project. And once it loads the project, you will see that 2D diagram or 2D drawing inside Revit here. So it's going to load that. It's going to look at all those equipments, all those schematic lines which you need to model and all that. So once the drawing is ready, we're going to start that drawing, and we're going to start working on that particular drawing inside Revit. So now, it's going to give you all those P&ID drawings, all the line dimensions, all the valves, all the fittings coming in from schematic stage here. And you can view the entire drawing directly here in the viewer as well. Now, this is how it looks inside here, but if I go here, I'm going to say I'm going to go to a next level. So once the drawing is visible, I want to go to another one. So all the lines are available here. You can select any one of the line and look at the details of that. So for example, if we select one of those lines here, like in this case, this one, so in that line, what are the connections and all that. Now, apart from that, when we start our project, we can say which is the service coming from schematic, and which is a service I'm going to map it within Revit environment. So you can say, for example, chilled water pipe coming from schematic will be mapped to a chilled water service inside Revit MEP here. And similarly, if you want to map the equipments like chillers, pumps, and all those kind of things, you'll be able to do the mapping as well. Now, so this is a very, very easy task to do here, and this is one time. If your equipments are same, if your schematic symbols are same, it's going to be one time, and you can save the settings inside the project also, and which you can use in all the projects moving further. So once you set up what object mapping happens, the which chiller or which pump or which service of the, for example, the pipe is going to be mapped here. So you set all those lines here, you set all the Revit pipe types assigned to them. So this is, for example, I'm going to use this particular pipe here, CS300 for the primary line segment. Which accessories coming from a schematic drawing, you're going to add them to this particular design. So you can say, okay, these are my mapping for the accessories. If there's a butterfly valve, for example, coming from a schematic, this is the valve I'm going to use in Revit. So you map the Revit families with the schematic symbols coming from the schematic drawing at the beginning of the project. And after that, everything is going to be automated once we do this mapping. And as I said, this mapping can be done one time in your organization. You don't need to do it every time if things are not different. So once this mapping is done, let me just move a little bit further here. And we start adding these ones. So I'm going to select a particular line. I'm going to say map to existing, assuming that you already have an existing equipment placed in there. So you can say, for example, this is the pump, which I'm going to map. So you select that centrifugal pump, and you can map it directly. Similarly, you can start creating the pipe network within the Revit. And you will notice here the colors. The green one means it has been mapped. Blue one means it's in the process. Gray one means it's not in this one. So now you see that there are different lines which went green compared to how they were earlier. That means these lines have been placed as per the schematic design. Now, if we go here, and I'm going to say I need to place this check valve, or I need to place this gate valve here. Now, if we look at the check valve, for example, so I'm going to say take the check valve. It's already mapped, so it will be the check valve placed, and it will go green automatically over here. Similarly, I'll say I'm going to have this gate valve. Now, look at the direction. I'm placing it on a wrong side, which is supposed to be on the upper side, as per the schematic drawing coming on here. If you look at the right side, the gate valve is on top, so it's giving me that error that this is not going to be working. And if you try to place it, it will take the other valve to a gray color, means it's not still correct. So it follows the sequence of valves or sequence of elements coming from a schematic, and if they are not mapped correctly as per their position, it will give you an error. It will highlight that this has been placed wrongly on a particular side. And once everything looks fine, once all those maps has been done between the schematic or P&ID as well as the Revit elements, you will see that this progress is green. On top, there's a green dot, means this service of the line has been completed successfully without any error as per the schematic. So that was the line I was working, and these were the valves which I placed coming from an P&ID mapped to the Revit elements. And this is the process we're going to follow for schematic. So schematic, we start in P&ID, and then we bring the P&ID into Revit, and we map this equipments and the service lines in Revit, and we start modeling it based upon how we actually do with the schematic here. Now, once that is done, and going towards design performance analysis, for example. Now, as an MEP engineer or a mechanical engineer in this case, so if you need to take up that model coming from an architect, and you need to optimize the building performance, you need to do the simulations for the energy or heating and cooling loads, daylights or the solar radiation in this case, or perform the lifetime change analysis over here. So what we're going to do here is, keeping the same in here, we'll take the Revit file, so which is going to be our authoring platform here for our model. We take it to something we call as Insight. So in the Insight, we'll be able to optimize the design, visualize the data, as well as analyze the performance here. So how it works here is, this is the Revit file. You can see I already have ducts and everything, but what I'm interested here is an architecture portion of it. So I can create automatically within Revit here the analytical model. I'm going to set the settings here so that I only see the analytical model, not the ducts and pipes and all those things here. So once I set the settings here, there's a one click on top of Revit. We say generate the insight for us. So the generate the insight is going to take it to this web browser. And within the web browser, you will see different parameters affecting that building performance on there. And you can select, and you can see here, what if I change, for example, in this case, the lighting efficiency, and if I change this lighting efficiency, what will be the effect? If I change the HVAC efficiency or type of equipment in the HVAC, what will be the impact on the heating and cooling on the performance of the building? Similarly, if I change the PV or surface coverage, whether I'm able to save some energy or not. And at any point of time, it's going to give you the dashboard. You can see what's happening in that particular building. If you're interested in a particular floor, you can go to the floor and say, OK, this is how much load density that floor requires. This is how much cooling and heating load that particular floor requires. So all the values are inbuilt. And once the results are then, you can see the results back inside Revit. It will also push back the data to those rooms which are created inside Revit. So you know exactly how much is the cooling, heating, as well as the airflow required for every room. Now, one thing in the Insight I just want to highlight here is that if you want to change a scenario, for example, you want to change orientation of the building. Typically, you will go to model, rotate it, and then do the next calculation. Whereas in the Insight, you do not need to do all those things. You can change a parameter without changing the model and see how it's going to impact the building which you are actually doing the analysis for. Now, if we need to take it to a next level, which is if you need to do a computational fluid dynamics, how the BIM as a workflow, as a connected workflow is going to help us. So in this case, I'm going to take Revit file to a CFD solution. So this is my Revit file here, and in this file, I'm interested to perform the thermal comfort levels in this case. So I simply launch from Revit. I'll send it to a CFD solution directly from Revit. And you will notice that all the walls, all the materials will be transferred. Just in case you need to edit, you can also edit them. You can run the simulation directly in here, and you can see exactly what is happening at what location. That's a fire simulation, so you can also look at the smoke coming inside that building, what it's going to impact. Or if you want to look at the thermal comfort level for a particular person sitting at a particular place in the room, you'll be able to get that thing done. So that is at the initial stage for a mechanical engineer when you start doing the concept design, taking it to detailed design, or you perform the analysis in terms of heating and cooling load analysis or CFD calculations. Now, next, I'm going to go into more details. And within those details, if you need to also go for the coordination, for example, I take the Revit file. I'm going to take it to, for example, in this case, to Navisworks. It's very simple workflow. In Revit, we simply export the file to a format which Navisworks takes as a Navisworks format. And in the Navisworks, I'm going to run, for example, clashes. I can select multiple services, or I can bring in the architecture and structure file here, combine all the files together, append them, what we call it here in Navisworks. So once that is done, I'm going to run the clash between a couple of services. I can choose a particular level. I can choose a level from a structure and level from an MEP. So once that level is selected, what happens here is you just run a test, and it will automatically highlight all the clashes happening in the project, and you'll be able to identify all the possible clashes. You'll be able to review them. You'll be able to assign them to the people who need to take an action. Like in this case, I'm going to say assign it to a particular structural engineer or structure detailer to amend this particular ways. Now, apart from that, there's also a possibility that you as a team work with an architecture team which is not in your office, or another team, let's say you are doing the mechanical and your plumbing guys are in different city, or they're in different country. So what we do here is using a solution like collaboration, platform for Revit, we are able to co-author. Like in this case, there are two people sitting in two different geographical locations. They are able to communicate directly from Revit, so they can talk. They can see who is saving the file from no matter where they are in the world. So this is something, a contextual awareness. Two people, you can ask for permission, you can ask for changes. When you update, everyone in that project is updated at the same time. So imagine working on a project simultaneously or concurrently, no matter where you are in the world, without setting up any IT hardwares and all that, and able to communicate within Revit environment to tell the people who you want to ask the information or provide the information. You can share the screenshots, you can share the updates, you can share, or you can communicate with the team and work it. And then you can, as I said, you can, load the other files here and see how it's going to perform. Somebody has asked for the permission, they changed the architecture walls, it's being updated directly here. And similarly, if I go here, I'm going to ask for someone, can I move them? If I have permission, I'll be able to move them no matter where I am in the geographical location, in this case again. So this is a highlight how, as an MEP team, you'll be able to work on a project no matter where the other people doing the same project are located in the geographical location. So you can simply, reply on all those aspects here. Now, if we go from the design stage to a detail stage, in this case, what I'm looking here is something called as LOD 400. So if you are aware about the LOD 400, is like a shop drawing. So if I need to create a shop drawing for an MEP fabrication point of view or installations point of view, I will be able to do that within Revit environment now. So what's going to happen here is I will be able to create the detailed spool sheets. I will be able to send my files for fabrication from Revit. I'll be able to produce shop drawings, ductwork, manufacturing, and installation directly from Revit as well. So just before I show you how that workflow works here is, this is very important to understand here is design teams, the fabricators, the detailers, the estimators, even the shop floor and the operations, they're going to share the same platform. So when I say same platform, means a database of information coming into Revit or coming into estimation software or coming into fabrication software is going to be the same. So there is no data exchange in terms of converting from one to another. It's going to be the same data available in all locations, whatever we choose. So there are a few solutions which I'm going to talk here, but this is something we call as CAD map. So CAD map is built on AutoCAD, which allows us to model or create this LOD 400 content. Now, what's great about this is the content available in the CAD MEP is already LOD 400, or it's a shop drawing or fabrication ready model which you'll be able to create, which you'll be able to detail, which you will be able to estimate, as well as send it for fabrication shops. Now, this is an example in case if I had an AutoCAD drawing and that AutoCAD drawing needs to be converted. So I'll be using that CAD MEP in this case. And then adding the values, for example, what the duct sizes and all that is going to be there. So I provide the length, and width of the duct, and I will start tracing on top of that 2D AutoCAD drawing, or it could be even a PDF file. You just bring it into here, and you can start tracing on top of it. And the detail level, the length of the ducts, the gauge of the ducts, and all those parameters are already set in the database. So you do not need to worry about any of those challenges which we may face. Now, moving further, if I want to go back to explain what we mean by LOD 400. So typically, if the top image, what you see here, is a consultant model, and the bottom image, what you see here, is actually a contractor's model, which they need to fabricate, which they need to install. Now, as you know, the consultants are not going to provide you the connection details. They will not provide the details about each and every duct, how much length is going to be and all that. And if you need to convert that consultant model or the design model to a contractor or an LOD 400 or a shop drawing model, there is a workflow which is fully supported by the BIM environments here. Now, this is if I need to model from scratch inside Revit. So the right-hand side, you see the content here. The content is coming from the fabrication solutions, and the same content we'll be using in other solutions as well later on. So this content is LOD 400. This is a fabrication-ready content. By default, it is DW144 as well as SMACNA. Specifications are already built in. Now, this is how I'm going to do it here. So if you're familiar with Revit MEP, it looks something similar inside Revit MEP, the modeling portion, whether you're modeling the ducts or whether you're modeling the pipes or the cable trays and all that, you can start looking at the solutions. Now, the beauty of these fittings, what you see here, or the beauty of these connections are, they are as per the specifications for fabrication. They come from a manufacturer content. So you do not need to worry about whether my fitting is correct or not. These are not generic fittings. These are ready for construction fittings by default. Similarly, if it was even a duct or a pipe, so you will be able to look at them, you'll be able to customize them, you'll be able to fabricate them at any point of time whenever you need them. All right. Now, there's also a possibility, as I mentioned earlier, if you need to convert an existing Revit model, which is done in Revit, or you receive from a consultant. So I have this database, or I have this content on the right-hand side. I'm going to change that Revit content to this particular content. So what happens here is, once I have this content ready, I'm going to select that particular ductwork. So I can select the whole ductwork in my entire floor plan, or I can just choose one duct, or I can just choose one system of the ducts. Now, in this case, I selected this one supply duct over here, and I want to convert that. So there's something we call as design to fabricate within Revit MEP. And what's going to happen is, you will not see any changes. The duct still remains the same duct, at the same placement, the same sizes, but it has replaced the duct with a fabrication duct. What happens with the fabrication duct is the moment I say optimize, it will divide that duct into the pieces which is required. Now imagine you do not need to worry about that whether the length of duct is as per the gauge, whether the length of duct is as per the width. This length of duct will be automatically cut as per the width of the duct, as per the gauge of the duct. So you don't need to worry about whether the ducts which I'm placing or the ducts which are here are going to be, whether they are the right gauge, whether they are the right materials and all that. That's all controlled by the specifications, which you can also customize if you need to. And once that is done, the next portion, what we're going to do here is, we're going to convert it, and after the conversion happens for all the fittings and all that, if I need to, I can go and place the hangers as well here to add a little bit more detail if I need to. And once that is done, you can see here I have my connection details in the left-hand side. You can see I have those cuts. If it is slip joint or if it is flanged, I will get the flanges and automatically. Now what I'm trying to do here is I'm trying to select everything and just export all those content which we created or converted to the fabrication, all the ducts, the fittings, and everything I just said, and I'm going to export them. Why I'm exporting them? Because I want to have the estimation. So I'll export from Revit. We call it as a fabrication job. So this will save to a file format. We call it MAJ. And that is it from Revit. So you converted your consultant model, or you converted from your Revit model to a fabrication-ready model. That's already done. Now, if we go back, and this is a package for estimation, I will open that file directly now. So what's going to happen here is you'll see that all the elements which you just exported from Revit are already here. There's no data loss at all because we are referencing the same library which Revit is using. You will find all those elements there. If you have added this hangers, you will find the hangers and everything. Now, once those are there, if you look at how the color scheme on the red, it tells you what's the percentage of chilled water flow pipes or the ducts of a particular supply and all that. That's a percentage, what you can look at it here. Now, if I want to go further to estimate it, so you have seen how I was able to export from Revit to a file format to estimation MEP. Now, once this is there, you'll be able to just say, tell me the estimate. It's there. So this estimation package, it considers everything what you're looking for the estimation for an MEP point of view. So if I go to the database here to show you what exactly is there, so I have the costing methods. I can also define the wastages percentage. I can define the overhead for my costing, or I can have my price lists. I can define the labor cost. I can define equipment cost, overhead cost, and you can change on the fly. For example, if the skilled labor cost changes from, let's say, €20 to or 20 pounds to 22 pounds, what's going to be impact of that on the overall cost? It will also distinguish between the cost of fabrication, the cost of installation, the cost of material, everything. You're going to get it directly from here. And if everything is ready, next thing is I'll be able to convert to a form of tender. So you'll be able to look at all the fittings, the cost, the materials, everything is here. Now, I just want to highlight one thing here. If you notice, it also gives me the sockets. It also gives me those end caps. It also gives me those tube, everything. I didn't model them. You don't need to model them, but for an estimation purpose, you need them, right? So if you're looking for a full estimation purpose, you need them. So what we do is, when we create a specification inside the fabrication solution, we tell it, if I have a slip joint, this is what nuts and bolts I'm going to use. If I have a hanger, a particular size hanger, that will be the size of nut and bolt. And automatically, when I get this one, it will automatically look how many of those hangers I have in the project. And it will tell me this is how many nuts, bolts, sockets you will need as per the requirement as well. So the costing will be there. The itemized list, everything is going to be generated automatically from this location. So that is the detailing portion, and that's the portion for the estimation also. Now, if I'm looking to connect this design to fabrication and installation in this way, now, I need to machine this. So I have my ducts which have been estimated. I have machines which have been documented, which have been detailed. I need to go to a next stage where I will be driving the fabrication of that. Remember, we exported a file from Revit. That's the same file we'll be importing into this solution we call it CAM duct. And CAM duct is a solution which connects the plasma cutters and coil rolls for ducting directly with this particular software. Now, this is how it looks. So you have the job imported here with all these contents, and you can look for the nesting. There's an automatic nesting or the manual nesting, which we can perform here. The parameters can be defined, means if there's a requirement of sheet sizes and all those parameters here, I'm going to simply say, OK, hit run, and just say OK. And in a matter of minutes, the entire project will be created as a spool. Now, you have the entire project, all that floor plan which you had in a particular type, which is a fabrication. Now, you also have a choice, just in case you want to manually go and change something or show what are the remaining parts. You can also modify, means shop drawings. If you have a similar, different sheet size, you can modify those locations and all that. And it also allows you to go and create your own scheme, create your own NCs, and fabrication ready. Or if I have the requirement, means those parts which we exported from Revit, we bring into this CAM duct. And I want to look at what is my, how much is the supply duct, how much is the return duct. And I want to print label for them. I want to print, because if I'm submitting someone, I need to give that person the identification of each and every equipment. So this is the quantity which we just fabricated over here. So I will also have all those requirements here. Now, I'm looking for something else, actually. I'm looking to print a label, which is going to be applicable on this case. So I'm not looking, I'm going to go to the labels here. I can print the item labels. I can print the part labels and all those kind of labels. So every equipment, every piece of duct, every piece of fitting, you'll be able to automatically generate a QR code or a barcode directly from the CAM duct. So you can look at those QR codes, or in case you need to go and stick a poster on each and every duct piece which you have fabricated with a clear nest point defined. So I'll be able to define, oh, this is how it's going to be nested, this is how it look like in a material point of view, and this is how it's going to be controlled. So that's all happening here in one solution. So you'll be able to design, you'll be able to generate this information in terms of labels. Everything is in one place. And similarly, if I'm looking for a different type of label, I want each and every piece of my duct, which is going to be fabricated, I want the part report. Means when I look at it, every equipment in a different one, what is my length, what's my width, what's the weight, what is the height, every information which I'm going to send for estimation and everyone. Similarly, if I'm looking at a different type of report here, which will be probably the label again, but in a different way. So I'm going to go for a part label. So the part label is every part, it will give me dimension of X, all length within the height. in a very nicely formatted. Now, by the way, these labels, what you see here, you can format them. You can define a logo from your company. Everything can be generated automatically for the entire project. So you can define what information you want on the label, what logo you want on the label, and once it is done, your project is ready. So it's all automated from a design till fabrication. You'll be able to generate everything what you need in one single solution. So the data flows from Revit to the fabrication for the estimation purpose, for the fabrication purpose, and as well as for the reporting. So reports can be generated, as I mentioned. So I can get like this particular report as different views of that particular fitting or part, as well as the dimensions, what are the different dimensions being generated or fabricated directly from this particular solution. Now imagine your design data, which was in Revit, and now you're taking for the estimation in an automated format, and after the estimation is done, you are taking it to fabrication, again in an automated format. There's no requirement for, whatsoever to do remodeling or rearranging anything. Everything you have done in Revit will be transformed to an estimation model, will be transformed to a fabrication model, and you'll be able to start working on top of it. Now, after that, once the model has been created, how do you take that model, or how do you take that BIM information onto the field? So one of the ways is that once you go to the site, you need to have control about where exactly is the hanger I'm going to put in there. So what we're going to do is we'll eliminate the paper and the tape measurements on the site. So I have my BIM model, I have my hangers in the model, I need the location of the hangers from the model. I will be taking them directly from the model versus tape measurements. As well as once the building has been constructed, I need to have an as-built. I can bring in the as-built data back to the same BIM model using the same workflow. The result is going to be very, very efficient way of installations on the site. So I'm going to use here the point layout, for example. So the key here is the model is coordinated. Model is ready for construction, which has been sent, and I'm going to take the data from here to this one. So again, going back to the same Revit file here, I have this plugin we call as a point layout. I'm looking to generate the points for everything, so I can generate the point for hangers in this case. So I'll say select all by default, so automatically all the hangers, the top location will be selected, and it will give me all those hanger points by default here. I can select the all points, or if you need to filter them out, maybe you might have for the whole building, but you just need basement points today. So you can filter them, you can export floor by floor, or you can export some points only. So once the points are ready, the hangers, you will also notice that there will be one single dot on top of a hanger, which is going to be placed. And if you had a Revit architecture slab or floor there, it will automatically go and attach to that floor as well. You do not need to, even if the floor goes up and down, the hanger length or the rod length will automatically change as well when it is required. So yes, you will be able to do the same for pipes, same for cable trays as well. Yes. Yeah. So if you remember, I was saying this model needs to be fully coordinated. That means you have already done the coordination, whether in Revit or whether in Navisworks. So you exactly know that this is the hanger location. And what we are doing, we're automating the process of installation. So you don't need to do tape measurements anymore on the site. Yeah. Absolutely, that is, that's a human thing. And there is, it reminded me something, maybe if I can show you later on. There's a new robot, as you've seen in the morning as well. There's a new robot available. What it does is it takes those points which I just exported, and it moves around to the site. It shoots a laser, and it goes to that particular floor slab, and it knows the coordinate as per your model, and it will drill a hole for that hanger one by one, without anybody doing anything. Yeah, that's true. That's why the coordination is very important, because that rebar is a human thing. That once this point has been placed or the hanger has been placed, it's no more decision from other point. So when you place the hanger, for example, it's the decision where you place the hanger is based upon how the person is looking at that structure over there, and how you coordinate with the structure versus other services. The coordination is still the key. So the key here is how do you coordinate? Means you have a fully coordinated model, then only you'll be able to take it to the installation purposes on that. All right, so this is a manual method, so I exported a CSV file. So just in case you have an old style of total station, which are manual ones, so I can go and feed this CSV file, and it will find all the hanger locations for me. Now, actually, this tool which I used here, we call it point layout. You can even use the points for walls, doors, windows, slabs, or any architecture element, any structure element. But I just use specific example here with the structure, MEP hangers. But it doesn't stop you for adding these points on any other devices or any other systems in the project. All right, so that is the file exported from here. And these are going to be the XYZ coordinates of that particular hangers, which you're going to look at the project. Now, you also have a choice later on to bring those points. For example, if there's already an as-built done, you can import the points from the total station, and you can generate the report telling you which points are not exactly as per the design points. So you will have a report generated telling you the design versus this particular point. Right? Now, moving further, for example, if I need to take this data to the field or the construction site, and I need to work with all those data, how I'm going to streamline the data on the field using the BIM workflows, migrating the data from my computer on the site, and how I'll be managing that. And what is the advantage of centralizing that project information with a shared database kind of thing. So one of the solutions here is like, this is what we call as glue here. And this glue will allow you to take your models on the site. So that will be the same one here. Now, glue also has one more application, which we call as layout. I don't have an example here, just to give you another look here. Remember, I exported those points as a CSV, right? Now, if you want, there is an application in the glue, which if you upload a file with the points inside the glue, there's an application we call as BIM 360 layout. And the BIM 360 layouts have a capability to connect to a robotic total station by Wi-Fi direct. That means if you have a hanger location defined on the model, this layout or this iPad will automatically trigger this total station and tell it exactly where this is. And the total station will shoot a laser pointer to the point where this hanger is going to be. So this is something like we say automated process in terms of workflow. Now, what it does is the robotic total station, the one which will be used with this application, is a one-man job, and frankly speaking, you do not need to have surveying, experience as well. If you are a BIM guy, your model is fully coordinated, you know exactly this is the point I'm going to construct. You can connect this application with a robotic total station, and it will take you to exact points for structure, for MEP, as well as architecture elements which you need to connect. So that's going to be very easy workflow over there. Now, similarly, from an information point of view, if I need to go and add some information in this regard, so the information can be taking your documents to the site, or taking those ducts, or taking those equipments which you have in the MEP project on the site, managing that handover process, managing the quality and safety processes on the particular site. So what I'm looking here is that this is an iPad capture of a BIM 360 field. So all the pipes, what you see here, or all the ducts which you're going to see here, are coming from a BIM environment. So these equipments, we call them equipments here, they come from a BIM environment here. Now, what I'm going to do here with that equipment is I will search one of the equipment, which is here, fan coil unit. When I'm doing the commissioning on that equipment, I'll be able to type in the information which is required. For example, I'm going to say here whether this equipment has a location defined. I can define, okay, this will be installed at this location. This has been installed or this has been delivered. I'll change the status of the equipment. Similarly, I will go ahead and also, okay, yeah, this one has a warranty. What is the material type, what is the pump size, the barcode. Go and, if you have a barcode or QR code, you simply go and scan that barcode or QR code, and it will capture that information directly from there. So remember, we exported the barcodes before for the ducts. Now I'm scanning those barcodes for the installation purpose for any equipment I need to. I can define the install dates, warranty dates, purchase dates. Now, just want to highlight one thing here before this moves further. If you have a requirement of as-built BIM, there are two steps which you always need to do in as-built. One is the location. So location, we looked at the point layout, how it can bring the locations back to Revit. Now, this is something which is going to give you as-built information. So you have a location and you have the information. So those are the two things which you need in as-built or LOD 500. Now, in this case, what I'm trying to do here is, if I have this equipment in this one, I'm giving this data or the date here. So that means I'm not required to type in on my, or write in on my diary later on. So all the information what you see here, I can also have predefined or pre-assigned checklists which I need to follow. So I can go and check these particular items for that particular fan coil unit when I'm at the site. I can look at if there was any issue on that equipment. I would have attached all my drawings, documents, and specifications to that equipment as well. And I will be able to assign the task. Means if you want someone to go and install this equipment or transfer from ground floor to the 5th floor, you can assign those tasks. And this is your BIM model. This is the same model which I converted earlier, and this is the equipment coming from the same file, which I can see now on an iPad, on an offline mode, on a construction site on a daily basis. So what I just did is I looked at that equipment, I provided the information to it, whichever I captured. What it does is, that information which you see here is captured, and now my purpose here is an as-built. So if I'm looking from an as-built point of view, I need to go back, I need this data back to where it came from. So this is where it came from, that was Revit, right? So from Revit, I had taken it to the site. I can see different colors, tells me different stages of my equipment. And if I go to this one, look at the left-hand side, that installation date, that asset ID, the tag ID, everything is coming from the site. Nobody is typing it. Nobody needs to add anything manually here. So all that information from the site coming back to your authoring platform over here is something which is as-built information. So you don't need to spend hours and months of time later on to enter this data or create the parameters for it. Now, the different colors over here tells me the progress. Like the green ones have been installed, the orange colored ones are actually still in the delivery phase, or it has been ordered. Similarly, if I look at that particular air handling unit, I have the information coming from site. I can see how many issues that equipment has on the site. And also, it has a link of all those attachments. So if I go and copy that link, paste it on a web browser, I'll be able to look at those attachments as well when it comes to the picture here. Now, I just want to frame it in one particular thing. For example, most of the products I spoke today is all in one package, versus the CAMDEC is a specialized software and a fabrication solution. CFD is a specialized software and estimation for estimation purpose, point layout, field, and glue. But most of the things which we have seen, including CAD MEP, giving you an ability of the databases, giving you the ability of those specifications to be used within Revit without investing more money on that. Now, I have a lot of questions to ask, but I want you to ask me questions. All right, so do you have any questions to begin with? Pardon me? Yes. Yeah. It is P&ID is intelligent because this is drawn in a software we call as AutoCAD P&ID. So where these lines are not actually AutoCAD lines, they are the P&ID lines, which has a link back to the specifications, which has link back to the database, where you can even take the quantities of those P&ID lines or those P&ID symbols and everything. Yeah, that's an intelligent one.
So I can get instrumentation list or line list.
Yes. you'll be able to get all those things in there.
And I can modify how I call the line or the instrumentation or the valve or whatever.
Yes, you'll be able to do that. It's customizable, and you can, just in a matter of fact, if you have a different symbol, for example, maybe because different countries use different symbol, like for electrical, for example, or for plumbing, you can customize your own symbol. It's like creating an AutoCAD block and saying, okay, this is my new symbol, and it will still work. That's not a problem. It will follow. Whenever you take your you can customize it as well. You can even set a process in terms of what line you can use for example, chilled water supply, what line you can use for chilled water return or ducts or pipes or electrical system. So you can customize it on that level as well. And at any point of time, whatever you have created in P&ID as a schematic, it's quantifiable. Means you can have all the quantities in terms of how many valves you have, how many pumps you have, how many other equipments you have, and it's connected to a database as well. Yes, it will show on the plan. It will show on the plan, as well as if you, for example, map it with Revit later on, it will, if you click on the P&ID, it will go and show you, okay, this is the equipment which has been mapped with that valve or with that line, and everything is done. So the purpose, this is the first time we included that, and that's the beginning of it. You'll see more improvements into that phase coming forward, where you will have more and more productivity happening between these two softwares to connect the schematic and the detailed design in one go. It's part of the package. There's what we call as an AEC collection, which has a Plant 3D, and the P&ID is a part of Plant 3D, and Revit is there anyways. It's part of Plant 3D, yeah. Yeah, CFD is a separate package. Yeah. Yeah. I agree on that. I agree on that. Now, there is something, we always know that Revit models at a detail level are over-designed or over-detailed for CFD purposes. So what we have seen people either remodeling it or converting. For example, from a CFD point of view, for this room, as an example, you don't need the doors, windows, information. What you need is a box. You need a 3D dimensions. So there is, you heard about Dynamo, right? So Dynamo, you can run a script which will convert the rooms to a 3D mass. And then you can take it to CFD, and you have all what you need without remodeling anything. You can use that as well. Any other questions? Do you think that's something which is useful to you guys? The entire workflow from a design till the installation, including the estimation, the fabrication, and all that. No, it's like, if you look at 10 years back when we started going with Revit, for example, so Revit was, say, from a presentation purpose, it's very simple. But when you start on the project, it becomes complicated day by day. I agree on that. So it's, I'm a mechanical engineer myself. I have worked on the field. But what it requires is just that particular setup, that particular workflow. So once you set up that process, these things will automatically fall in line. So when I was creating that, for example, converting the duct to a particular fabrication duct, it was happening automatically because I have set that parameter. I know what is going to fit in there. So once you set up that inside your organization with the processes, it will automatically work. So it requires that investment of time and effort in the initially, and then later on it's going to be automated process for you. All right, so just in case you don't have any questions, I think I'm done then. Thank you very much.